Hi everyone. So till now we have studied Maxwell's equation. We have understood the meaning of Maxwell's equation. Then we saw the Maxwell's equation in phasor form. And in the last lecture we analyzed a very important function which was E naught cos omega t minus beta z ax cap. So everything that we wanted to know about this function that we studied. Right? Now we need to understand the EM waves. So using the Maxwell's equation, now we are going to understand the EM wave. So first we will see the intuition that how EM waves are generated, and then we will see the mathematical derivation. So first we will start with the intuition, but before going into the intuition we need to know a few things. So let's solve a question. I hope you remember the curl operation. We have studied the curl operation. So from based on that there is a question. So the direction of vector field A at about a point P is shown. This is the direction of vector field A. This is the direction of vector field A. About a point P is shown. You need to show the direction of del cross A. Do you remember how do we define the direction of del cross A? So this is your vector field. This is your circulatory vector field. How it is going? It is revolving in anti-clockwise direction. So I will use my right hand anti-clockwise direction. So my thumb is pointing upward. So this will be my direction of del cross A. I hope you remember it, how to find the direction of del cross A. If you don't remember, then now you can understand. So this is how we can find the direction of del cross A. Field is in anti-clockwise direction. My hand will be del cross A. Sorry, not hand. My thumb will be del cross A. So this will be my del cross A. This will be the direction of del cross E. What about this? The field is clockwise. So I will rotate my hand clockwise, right hand. Okay. You need to rotate your right hand and it will point downward. So what is the conclusion here? That my direction of del cross A is always perpendicular to the rotation of field. My field is rotating in this plane. So my direction of del cross A is perpendicular to the rotation of field. Right? Is that clear to you? We will be using all these things. So that's why I am dealing it here. Now I have shown the direction of del cross A. The direction of del cross A has been shown. So what will be the direction of the field? Direction of del cross A has been shown. So this is the direction. This thumb is the direction. So direction of field will be what? Anti-clockwise. And that will be perpendicular to the plane. Sorry, no, perpendicular to this vector. So this will be the direction of del cross A. Sorry, this will be the direction of A. If A is in this direction, then del cross A is perpendicular. So just the opposite equation I am asking, nothing else. And what about this? This will be, it needs to point downward. Del cross A is downward. So it has to be clockwise. Right? Clockwise pointing downward. Now we have studied this Maxwell's equation. Del cross E is equals to minus del B by del T. Del cross H is equals to sigma E del D by del T. For now, let's assume sigma is 0. Forget about sigma. So what did I tell you? Time varying magnetic field generates a space varying electric field. But from now onwards, what will I say? Time varying magnetic field. The magnetic field is time varying. Certainly it is space varying as well. From now onwards, electric field and magnetic field both are space varying. Electric field and magnetic field both are space varying. So time varying magnetic field, time and space varying magnetic field generates time and space varying electric field, and time and space varying electric fields generates time and space varying magnetic field. So both are complementary. Are you getting this point? Time varying magnetic field generates space varying electric field. Space varying and time varying electric field generates time varying and space varying magnetic field. Time varying and space varying magnetic field generates time varying and space varying electric field. Magnetic field, electric field, electric field, magnetic field, magnetic field, electric field. So both are complementary to each other and they will keep on generating the fields. Is that clear to you? This is what I have written. Space and time varying magnetic fields generate space and time varying electric field, and the space and time varying electric field generates space and time varying magnetic field, and this cycle goes on. Let's solve some question. The direction of time varying B is shown. You need to show the circulation of electric field E. What do I know? Del cross E is equals to del B by del T. Right? Minus sign is there. Certainly minus sign is there. Del cross E is equals to minus del B by del T. So they have shown the increasing direction of B. That means this is the direction of del B by del T. They have shown the direction of del B by del T. I am writing dB by dt del T, but it should be written as del B by del T. Okay. Now one thing I know that the direction of del cross E will be opposite to del B by del T. So direction of del cross E will be this. This will be the direction of del cross E. Now if this is the direction of del cross E, if this is the direction of del cross E, then what will be the direction of field B? The direction of field B will be this, not B, sorry, the direction of field E. This will be the direction of field E. Are you getting this point? This is the direction of B, del cross E is opposite. If I know the direction of del cross E, then certainly I can tell the direction of E. Here I knew the direction of del cross A. If I knew the direction of del cross A, I could tell the direction of E. So certainly if I know the direction of del cross E, then it is clockwise, rotating clockwise. So from here what did you get to know? B and E are perpendicular to each other. If this is the direction of B, then E will be in the plane perpendicular to B. Again I am saying, if this is the direction of B, then E will be in the perpendicular plane perpendicular to B. Is that clear to you? B and E are perpendicular to each other. Similarly, if the direction of E is shown, so what do I know? Del cross H, this equation I know, no? Del cross H. So del cross H, sigma for now I am taking 0, like it would be sigma E plus epsilon del E by del T, because D is equals to epsilon E. So epsilon I am taking out. So for now I am assuming sigma equals to 0. Now this is the scene. So direction of del E by del T is shown. Direction of del E by del T is shown. This is the direction of del E by del T. Now what is the direction of del cross H? The same. The direction of del cross H is the same. This is the direction of del cross H. If you know the direction of del cross H, can you tell me the direction of H? Where will be the circulation? The circulation will be in the plane perpendicular to del cross H. The circulation will be in the plane perpendicular to del cross H. So this will be the circulation, and the circulation will be in anti-clockwise direction. The direction is not important actually. It is in anti-clockwise or clockwise. This is not important, but the concept is, if my electric field is this, then my magnetic field is this. Are you getting this point? Yeah. So if my B was changing in this direction, then my E was changing in this direction. If this was the direction of B changing, then this was the direction of E. Now, if this is the direction of E changing, then this is the direction of B. So E and B are perpendicular to each other. So what is the conclusion? Time varying electric field generates time and space varying magnetic field in the plane perpendicular to E field. Time varying electric field generates time and space varying magnetic field in the plane perpendicular to E. Right? And time varying magnetic field generates a time and space varying electric field in the plane perpendicular to B. Both are complementary to each other. Is that clear to you? Now the concept of EM wave will be crystal clear to you. Okay, you will be able to see the EM wave. So let's start here. Let me erase it all. Okay, I will draw all these again. Yeah, so I have erased everything. Now let's start the analysis. So this is your x axis, z axis and y axis. X, y, z axis are there. Along the x axis, you have a current carrying wire. Now in this wire, the current is time varying. Along x axis you have put a wire and the current is time varying. The current is changing with respect to time. Now if there is a current carrying wire, then it will generate a magnetic field. You know this thing, right? Current carrying wire, it will generate a magnetic field. This we have already studied in the basics. So current carrying wire is there, so it will generate a magnetic field. So it has generated a magnetic field. Now what will be the plane of magnetic field? YZ, because this is the current and magnetic field will be in YZ plane, right? Now this magnetic field will also be time varying because the magnetic field is proportional to current. If current is varying, then magnetic field will also be varying. Now one thing you know, a time varying magnetic field generates a space varying and time varying electric field. This is a time varying magnetic field. It will generate an electric field as well. So let's understand the direction of electric field on this point. Let's understand the direction of electric field on this point. What is the direction of magnetic field on this point? What is the direction of magnetic field? The direction of magnetic field. How will you get the direction of magnetic field? You will just, at this point I am asking, so what you will do? You will draw a tangent here. You will draw a tangent. So I am drawing a tangent. So where will that tangent go? In minus ay cap. Are you getting this point? This is your electric field. This is your electric field. Not electric field. This is your magnetic field. This is your magnetic field. I am drawing a tangent here. This is the tangent I have drawn. So it is going into minus ay. No? So this is the direction of time varying magnetic field, not electric field. This is the direction of time varying magnetic field. Now, if this is the direction of H, then what will be the direction of E? If this is your H, so what do you know? Del cross E is equals to minus del B by del T. So if this is the direction of H, then this will be the direction of del cross E. And if this is the direction of del cross E, then what will be the direction of E? The direction of E will be this, right? This will be the direction of E. Is that clear to you? Again I am explaining. Okay, I know it is a typical point. The H is going inward. If H is going inward, then what will be del cross E? This is your del B by del T. This is your del B by del T, right? Del B by del T. So del cross E will be opposite. If you know the direction of del cross E, what will be the direction of E? This we have already taught, no? If I know the direction of E, if I know the direction of del cross E, then this will be my E, right? So same thing I am doing. This is my H. So del cross E is here. So rotate the hand in this direction. This is the direction of del cross E. So this will be your electric field. So this time varying magnetic field generated a time varying electric field as well. Now this electric field is in which plane? This electric field is in which plane? In XZ plane. Do you agree to this point? This electric field is in XZ plane because this was your minus y. This was your minus y. This was your minus y. And electric field will be around this. So it has to be in XZ plane. Are you agreeing to this point? Now, if I draw a slope at this point, where it will show upward. So at this point, this is my electric field direction. At this point, this is my electric field direction. So if I know the direction of E, then what do I know? Del cross B is equals to epsilon del E by del T. So if I know the direction of del E by del T, then what will be the direction of del cross B? This will be the direction of del cross B. At this point, this is the direction of del cross B. If you know the direction of del cross B, then what will be the direction of B? In the plane perpendicular to del cross B. If I know the direction of del cross B, then what will be the direction of B? The direction of B will be in the plane perpendicular to del cross B. This will be the direction of B. So this is how it should rotate. This is how. Rotation is not important, but you can see rotation is like this. This will be your del cross B. Is that clear to you? Let me explain again. Okay, let me explain all these things again. So there was a current carrying wire. Just a second. Yeah. So there was a current carrying wire. Then it generated a time varying magnetic field. Time varying magnetic field was pointing inward at this point. At this point, it was pointing inward. So if it is pointing inward, so this is the direction of B. Del B by del T. That is the direction of del B by del T. So what will be the direction of del cross E? This, AY. So what if I know the direction of del cross E? Then what will be the direction of E? On this plane, right? This is the direction of del cross E. If this is the direction of del cross E, then what will be the direction of E? Perpendicular to the plane containing del cross E. This is the direction of del cross E. Then E will be in the plane XYZ. Sorry, XZ. Then E will be in the plane XZ. Is that clear to you? Right? This should be clear. Like we have taken a lot of examples. I could have directly told this thing, but you would not be understanding. But if we have taken this example that this is the direction of E, then this is H. If this is the direction of B, then this is E. Right? Now at this point, what is the direction of E? If this is the direction of E, then this is the direction of B. If this is the direction of E, then this should be the direction of B. Right? This should be the direction of B. Now at this point, what is the direction of B? Inward. If this is the direction of B, then what will be the direction of E? Again circle, right? Now again at this point, if this is the direction of E, then what will be the direction of B? Again perpendicular. Then this cycle will keep on going. So what do you see? What are you seeing here? So this was your H and this was your E. H is generating E is generating H is generating E is generating H, and both are perpendicular to each other. H generates E generates H generates E generates H, both are perpendicular to each other and they are walking in plus Z direction. Is that clear to you or not? This is how the EM wave propagates. This is the core concept of EM wave. Like, you are able to see the EM wave now. This was your source. This is acting as a source, right? What did I do? I just got a wire. I produced time varying current. Because of the time varying current, I am having EH. So my E, this is the direction of E. E is dancing in plus X and minus X. This is the direction of E. Where is E? You can see, right? This is your E. Pen. Just a second, I need to pause the video. I got too excited. My pen. Okay, I am having another pen. Okay. Yeah. So this is the direction of E. Right? And what is the direction of H? This is the direction of H. This is the direction of E. So E is dancing in plus X and minus X. H is dancing in plus Y and minus Y. And where they are going? They are going towards plus Z. Is that clear to you? Right? I hope you are able to see. And this is how it will look like. H is dancing in Y. X is dancing in X. And they are moving towards Z. Is that clear to you? I hope you are able to visualize. Let me show you the simulation as well. Yeah, so again, this is the same website, ophysics.com. Okay, so credit goes to them. You can see now, this is how they are dancing. E is dancing, H is dancing, and they are moving ahead. So this is your electromagnetic wave. Is that clear to you? This is how electromagnetic wave propagates, right? Let's get back to our concepts. Yeah. Now, one thing is that people will have one doubt that, sir, why did you assume only the direction here? Like, why you did not make a tangent here? If I have made a tangent here, then this will be the direction of E. Then because of E, I would have generated another B. Then because of B, I would have generated another E. Then EM wave could have propagated in this manner as well. Are you getting this point? If I had made a slope here, then EM wave would have, then I would have got E. Then because of E, I would have got another B. So EM wave could have propagated in another direction as well. So there could be multiple direction of EM wave propagation. Yes, that is true. There could be multiple direction of EM wave propagation. That is true. But when we study EM wave, to study the EM wave, like we need to get some expression and then we need to study it. Mathematically, we need to study it. So when we are studying it, we will consider only one dimensional motion. Like this is correct. Now people will have a doubt that, sir, H is there on a circular way, right? This is the circulation of H. So on multiple points, there will be multiple electromagnetic fields. Like because of magnetic field, you will have a electric field. Then because of electric field, you will have a magnetic field. So there could be multiple direction of that. That is true. There is no doubt about that. But when we study EM wave is nothing but a electromagnetic wave. EM wave is nothing but electric field plus magnetic field. And electric field and magnetic field are going into some direction. So that is acting as a wave. So this will feel like a wave, right? H is going like that. So this is feel like a wave. So that's why it is known as EM wave. EM wave means there is time harmonic electric field, there is time harmonic magnetic field. It can propagate in a lot of direction, but when we study unidirectional. Okay, we will only take one dimension. So here I have written, when we study EM wave, we assume only one dimensional motion. Okay, so this is how we will assume it. So certainly there will be a lot of direction, like certainly electric field and magnetic field would be changing in other direction as well, but to study that we will take only one direction. Okay. Now tell me one thing. Here the direction of this is the direction of, this is your minus x, right? So what is the direction of E field? Minus ax cap. And what is the direction of H field? Minus ay cap. And what is the direction of propagation? Az cap. So can you tell me one thing, that minus ax cap cross minus ay cap is equals to az cap? Do you agree to this point? So direction of electric field cross direction of magnetic field, or better I should write direction of electric field cross direction of magnetic field will give us the direction of propagation of EM wave. P is equals to E cross H. P is equals to E cross H. Electric field was dancing in X, magnetic field was dancing in Y, propagation was in Z. Is that clear? Say yes or no. Are you able to visualize? We are not going into mathematics. First, I wanted to give you the intuition that how you can see the electromagnetic wave. So this is how you can see, and this is a picture at a certain time. This is a picture at t equals to constant. But if I vary the time, then they will start moving towards Z. Right? Everything is crystal clear. And we are studying only one dimensional motion. Right? So with respect to this diagram, can you write down the electric field and magnetic field expression? Can you write down the electric field and magnetic field expression? How will I write down? What is my E field? E field is my, look, it is a function of space. Function of space. Is it a function of time? Yes. Is it periodic in nature? Yes. E produces H, H produces E, E produces H, H, E, H, E. Is this periodic in nature? Yes. If all three conditions are satisfied, then what is this? Time harmonic field. And do you know how to write down the expression of time harmonic field? Yes. E is equals to E naught cos omega t minus beta z. And in which direction it is going? Here it is going in negative x actually. It is going in negative x. But what we can take, here I am writing Ex cap, okay. Actually it is going in negative x. It is, as per the diagram, it is going in negative x. This is the direction of electric field. I should have shown this is my electric field and this is my magnetic field. This is your x, y, z. But look, forget it. What I am gonna do is that I am gonna change the axis so that there would be no confusion. So this I am making as x. This downward is x. And this I am making as y. The other one I am making as y. Okay. Now everything will be, no doubt will be there. X, y and z, minus minus sign I am ignoring. Okay. So now electric field is in x direction only. Magnetic field is in y direction only. And x cross y, look, x cross y. You need to use this hand. Ex cap, Ey cap. Yeah. So you can use your this hand. You can see that x cross y is giving you z. Right? We just made it opposite. This was your x, minus x this was, but this has been made x and this has been made y. So x cross y is giving you z. So that's it. So this is how I can write down the equation. Is this the only way of writing down the equation? No. Actually, there could be three possible ways. How you could have written? There was three possible ways. E naught e to the power minus j beta z e to the power j omega t, or you could have taken real part of that, or you could have taken imaginary part of that. There are three possible ways of writing down a time harmonic vector field, but we will take the real part for analysis purpose. what we will take? We will take the real part. And what will be your H field? H field will be H naught cos omega t minus beta z ay cap. This will be your H field, right? So these I have written down. So from here, what did you get to know? That your electric field is perpendicular to magnetic field and it is perpendicular to the direction of propagation, right? If direction of propagation in z, then certainly there will be no component of electric field in z direction. Did you understand this statement? If the direction of propagation is z, then certainly there will be no component of electric field or magnetic field in z direction. Direction of propagation was z. The electric field is in x direction and magnetic field is in y direction. They are propagating in z direction, but their components are in x and y. So certainly if I say that my magnetic field in, if my wave is propagating in z direction, then my component could be in either x direction or y direction. There will be no component in z direction. Do you agree to this point? I will be using this point during the derivation. So at that time you should not have the doubt. There I will again explain that if it is working in z direction, then component could be in x or y. It can never be in z direction. Is that clear to you? Now we are going to study the derivation of EM wave equation, but before that we need to understand few points. So what do you mean by lossy medium or lossless medium? So lossless medium means this is your lossless medium. This box I have made, that is a lossless medium. So my EM wave was coming. When it went through this lossless medium, there was no attenuation. No attenuation. Attenuation means the amplitude was same as before. Whatever the amplitude E naught, E naught, E naught, E naught, E naught, always it is E naught. So no attenuation. So that means lossless medium. There is no loss. And lossy mediums means yes, there is attenuation. Very simple. Wave was coming, there was no loss, so no attenuation, so lossless medium. If there is a loss, initially the amplitude was E naught. It was always E naught. Just as it went through this medium, the amplitude is going down. So when it went out, the amplitude is very less. So this is known as lossy medium. Okay. Now, based on conductivity, there are three kind of medium actually: conductive, non-conductive, and dielectric. Three kind of mediums are there: conductive, non-conductive, and dielectric. So what do you mean by conductive? It will conduct the current. Okay. There will be conductance. So conductance means sigma will be not equals to 0, or I should say sigma will be very high. Conductivity will be very high. What do you mean by dielectric? So dielectric medium is non-conductive medium only. That means there will be no conductivity. In dielectric medium, ideally there should be no conductivity. Ideally sigma should be equals to 0. But no, there are two cases. Because dielectric medium can conduct at breakdown. You are not understanding anything, right? What sir, what are you saying? So from this slide, what you need to remember: conductive medium, that means sigma is very high. Dielectric medium, there are two kind of dielectric medium: lossy dielectric and lossless dielectric. Okay, there are two kind of dielectric medium: lossy dielectric and lossless dielectric. Lossy dielectric means there will be sigma not equals to 0, and lossless dielectric means sigma is equals to 0. You don't need to mug it up. You will eventually going to remember it. You will eventually remember it. So do not worry about it. Just you see this slide. There could be two kind of medium: conductive, dielectric. Conductive means certainly sigma will be very high. Sigma will be non-zero, right? Sigma is what? Conductivity. This we have already studied. In dielectric medium, there will be two kind of mediums there: lossless and lossy. Lossless dielectric means sigma is equals to 0. So this is perfect insulator or perfect non-conductive medium. And this is your lossy dielectric. So basically here sigma will be non-zero, but it would be low. Look, in both of the cases, in conductive as well and in lossy dielectric as well, sigma is non-zero. But here sigma will be very high, here it will be low. Is that clear to you? You don't need to mug it up. These mediums will be used again and again. That's why we are studying it here. Is that clear? Okay. So as of now, do not mug it up. Just see that I know what is conductive medium, I know what is dielectric medium, I know what is lossless, I know what is lossy. That's it. Let's move ahead. So types of dielectric medium based on sigma, mu and epsilon. Sigma is the conductivity, mu is the permeability, and epsilon is the permittivity. Is that clear? This is associated with conductive medium, right? Ideally, dielectric should have sigma equals to 0. So this is associated with conductive medium. So let's see what do you mean by linear, isotropic and homogeneous medium. So these terms will be again and again used, that this medium is linear, isotropic, homogeneous. So what do you mean by that? Linear means D should vary linearly with E, B should vary linearly with H, and J should vary linearly with E. Like if I draw the graph between D and E, it should be linear. That is known as linear medium. Same goes for B, H, and J, same goes for J and E. So that is known as linear medium. So if I say D is equals to epsilon E, now let's assume my epsilon is some 3 E naught square. This is the value of epsilon. What is the value of epsilon? 3 E naught square. This is the value of epsilon. Epsilon is a function of E, not E naught square, E square. Epsilon is a function of E. Epsilon is a function of E. So what I will write, D is equals to epsilon E. So 3 square into E. What I will get? 3E cube. So D is equals to 3E cube. Is there linear relation between D and E? No. But if your epsilon was 3x, let's just say your epsilon was 3x, where x is the space coordinate. X is the space coordinate. So if your epsilon was 3x, then yes, certainly there is a linear relation. If I draw the graph of D versus E, it will be linear and the slope will be 3x. Right? Is that clear to you? If it is the function of E, then there is an issue. If it was the function of E, then there is an issue. Right? Same goes for B is equals to mu x, mu h. If it is a function, if mu is a function of h, then there is an issue. If sigma is a function of E, then there is an issue. So epsilon, mu and sigma should not be a function of E and h for linear medium. Is that clear to you? How will you remember? Linear medium. Okay, D should vary linearly with E. So that means if I want linear relation, so epsilon cannot be a function of E. Same goes for mu, same goes for sigma. Isotropic medium, we will discuss about it. Okay, we will discuss about isotropic. Let's study about homogeneous. What do you mean by homogeneous medium? Homogeneous is associated with space coordinate. Basically, epsilon, mu and sigma should not be a function of space coordinate. So in the previous example, I said epsilon is equals to 3x. So this is not homogeneous. Okay, epsilon equals to 3e square. That will work for homogeneous. It will work for homogeneous. But epsilon equals to 3e square, it will not work for homogeneous medium. So homogeneous means your epsilon is not a function of x, y, z or rho, phi, z or r, theta, phi. Okay, so it should not be a function of space coordinate. Let's understand what do you mean by isotropic medium. So isotropic medium is associated with the direction of D and E, B and H and J and E. So what does it say? The direction of D and E should be same. So what is D? D is epsilon E. So who can change the direction? Epsilon. But epsilon is a vector quantity? No. Epsilon is a scalar quantity? No. Epsilon is a tensor quantity. And what do you mean by tensor quantity? In different directions, it can have different value. Do you remember the example of a polythene? If I make holes here, then in this direction, 5 liter water is coming out. In this direction, 7 liter water is coming out. In this direction, 9 liter water is coming out. So the direction of flow of water is different. And the magnitude is also different, 5 liter, 7 liter and 9 liter. You can say that in this direction, 5 liter water is flowing out. In this direction, 7 liter water is flowing out. In this direction, 9 liter water is flowing out. So same goes for epsilon. Epsilon is a tensor quantity, not scalar. Epsilon is a tensor quantity. So with respect to different direction, it can have different value. Like in xx direction, it is having epsilon xx value. In xy direction, it is having epsilon xy value. In xz direction, it is having epsilon xz value. So it can have different value in different direction. So with respect to three axes, it can have 9 values. Okay. So let's just say this is my D, this is my E. D is dx ax cap plus dy ay cap plus dz az cap, and E is ex ax cap, ey ay cap and ez az cap. And the relation is D is equals to epsilon E. So how will I write down the value of dx? So dx will be epsilon xx Ex plus epsilon xy Ey plus epsilon xz Ez. Now tell me one thing, there are two vectors, 2ax cap plus 4ay cap plus 6az cap, and another vector is ax cap plus 2ay cap plus 3az cap. Do they have the same direction? Yes. Why is that so? Because you can take 2 common. If you need to know the direction of this, what you will do? 2x cap plus 4ay cap plus 6az cap, and then divide the magnitude. That will be 4 square plus 2 square, 4 plus 4, 16, 36, whatever you get. It will be 54, I guess, whatever that you get. And once you see, the unit vector will be same. Unit vector will be same because these two are linearly related, right? If you want the same direction, then dx should be equals to ex epsilon x ex. Now if your dx is a function of ey, then certainly there cannot be the same direction. Are you getting this point? Dx cannot be a function of ey, dx cannot be a function of ez, dx has to be a function of ex. Here I can write down that if this is your a vector and this is my b vector, then I can write down b vector is equals to 2a vector. If I need to write down that d vector is equals to epsilon e, then certainly epsilon can be varying only in x direction. If these two components are 0, then I am okay with that. What do I mean to say is that if this is 0 and this is 0, then it is fine. Are you getting this point? This is a bit typical point. Epsilon can have 9 different values in different directions. But I want the direction of dx and ex to be same. Basically, I want dx is equals to epsilon x ex for isotropic medium. For isotropic medium, I want dy is equals to epsilon y ey and dz equals to epsilon z ez. So how will I get that? If I solve this matrix, then exy and exz should be equals to 0. Right? Just a second. Okay, forget about it. Yeah. So this is the tensor quantity. So for an isotropic medium, epsilon matrix should look something like this. Say yes or no. These values can be different, right? These values can be different. But if you want the same direction, then certainly it has to be dx is equals to epsilon xx ex, dy is equals to epsilon yy ey, and dz is equals to epsilon zz ez. It will not be used anywhere, okay? Do not worry about it. It will not be used anywhere. It will not be asked in your examination. Just you should know that if these terms are introduced in your question, then you should know what is the meaning of these terms: linear, isotropic, and homogeneous. So if I say my epsilon is equals to 3 epsilon naught, is this linear, isotropic, and homogeneous medium? Yes. Because it is neither function of space. Here, this is neither function of 3 epsilon naught. Epsilon naught is a constant quantity. Epsilon naught, do you remember the value? 8.85 into 10 to the power minus 12. That is the value. And what was the unit? Farad per meter. So this is a constant value. This is also a constant value. If epsilon is constant, then there is no issue. Are you getting this point? Epsilon is not. If epsilon is constant, then it is linear as well. It is homogeneous as well, and it is isotropic as well. Right? So basically, this is something you need to remember, that if they are saying that your medium is linear, homogeneous, and isotropic, by default your medium would be linear, isotropic, and homogeneous. So these terms might be mentioned in your question. That's why we are studying it here: linear, isotropic, and homogeneous. Okay, so this is the meaning. You don't need to mug it up. How you can remember linear? Very easy. D and E should be linear. Isotropic. Have you ever heard of this word ID? Identification, ID, Facebook ID, Instagram ID. So I is associated with the direction, and then homogeneous will be associated with the space. Right? Homogeneous is associated with space coordinate x, y, z, and I is associated with the direction. So isotropic means associated with direction. So direction means epsilon can have different values in different direction. Okay. So let's remove it off. Yeah. So this is the conclusion. Basically, this is the conclusion. So sigma mu and epsilon, sigma, mu and epsilon. If they are not varying with E and H, basically if they are not function of E and H, then linear medium. If they are constant in all the direction, in x, xy, if they are constant, then it will be isotropic. And if it is not varying with space, then it will be homogeneous. And epsilon is equals to epsilon naught epsilon r, mu is equals to mu naught mu r. There is one more term that is known as charge free medium. What is the term? Charge free medium. So charge free medium means rho v is equals to 0. What is rho v? Charge density, right? Volume charge density. So what is rho v? Volume charge density. So from now onwards, all the mediums will be linear, okay, isotropic, homogeneous, and charge free. Again, I am saying from now onwards, what you are going to do, you are going to analyze EM wave in different mediums. You are going to analyze EM wave in different medium, in conductor, in dielectric, in free space. So all the medium will be linear, isotropic, homogeneous, and charge free. Is that clear to you? In the examination, 99.999% I am sure that the question that would be coming from linear, isotropic, homogeneous, and charge free region. That's for sure. So that's why we understood all these points here. Is that clear to you? Okay. Now let's study. What we are going to study? We are going to study the analysis of EM waves. So there would be some mathematics used there. There will be some mathematics will be used. So let's understand that mathematics. So this formula will be used there. Del cross A. Okay. Del cross A. What is the answer for that? Del dot A into del minus del square A. Will you be able to remember? Just write it down in your rough notebook. Del cross A. Del dot A. Just for the derivation purposes will be used. Minus del square A. No question will be coming in your examination. From this formula, no question will be coming. But you just need to understand that this will be used in your derivation. So del dot A into del minus del square A. Okay. Then there is a Laplacian operator. This is your Laplacian operator. So this we are going to study about. So Laplacian operator. So Laplacian operator on a scalar function. How do we define that? Del cross phi. So that is defined as del square by del x square into phi. Basically, you need to differentiate phi with respect to x twice. Differentiate phi with respect to x twice. First you do this thing, then again you do del y del x. Okay. So del square phi upon del x square. Same goes with respect to y as well. And same goes with respect to z as well. Now, if it is performed on a vector quantity, then what you are going to do? So what you are going to write, this is your vector quantity, ax cap plus ay cap plus az cap. Then what you are going to do? Del square a. So what you are going to write? What is a? Ax cap plus ay cap plus az cap. So from here what you will get to know? Del square ax plus del square ay cap plus del square az cap. Then separately you will calculate del square ax. What will be your del square ax? Plus del square del y square ax plus del square del z square ax. Now ax can be function of anything, like ax can be 3zy, this ax can be 3zy, like vector field A is 3zy ax cap plus 2xz ay cap plus 3yz az cap, right? So your ax is 3zy. So you are going to calculate del square ax. So del square by del x square 3zy plus del square by del y square 3zy plus del square by del z square 3zy. Then whatever the answer you get, you will put that answer here. So that will be your del square a vector answer. Only for ax cap. Then you will do the same thing for this. Then you will do the same thing for this. This will not be asked in your examination, but I will be using it in the derivation. So that's why we are seeing it here. But because if I do all these things during the derivation, then you will not be able to understand. So is that clear to you? First formula, what did we study? Del cross A. So del into del dot A minus del square A. Laplacian operator is del square. So del square phi is del square del x square phi, del square del y square phi, del square del z square phi. Then I need del square E. So del square ax cap plus del square ay cap plus del square az cap. Del square ax separately I am going to calculate. So this is like a scalar function only, no? Actually, Laplacian operator is never defined on vector. When you are using the definition of Laplacian operator, then you are performing it on a scalar quantity. What do I mean to say is that Ax is a scalar quantity, right? A is a vector, but Ax is scalar, no? Ax was 3yz. So this is a scalar, no? So if I say the Laplacian operator is performed on a scalar quantity, that statement is absolutely correct. But sometimes people get confused that, sir, you just said that it is performed on scalar, but now you are performing it on vector. Actually, we are not performing it on vector. We are performing it on the Ax, Ay and Az. So now this is a scalar quantity only. So this I will perform, then I will put here. This I will perform, then I will put here. This I will perform, then I put here. So 3 separate calculation I am gonna do, and then I will put there, and that will be my final answer. So this will not be used in our like this. No questions will be asked, but this will be used in our derivation. So that's why we are studying it here. Is that clear? Okay. Now I hope you would be knowing this simple mathematics in elementary classes. In 11th 12th class we study it. Then how to represent a complex number in polar form. You need to represent neta is equals to a plus iota b, or you can say j beta in the polar form. What do you mean by polar form? So in polar form, you write down the magnitude. Along with that, you write down the angle. So what will be the magnitude of this? Magnitude will be root a square plus b square. And what will be the angle? That will be tan inverse b by a. Right? Same goes here. What will be the magnitude? Magnitude will be 1 by root a square plus b square. And what will be the angle? Since it is 1 by, so minus sign I will use. Tan inverse b by a. Is that clear? Magnitude, how will you write down? 1 upon a square plus b square under root. And what will be the angle? 1 by it is, so minus tan inverse b by a. What about this? What will be the magnitude? Under root a square plus b square and then under root, right? What is the magnitude of a iota b? That is root a square plus b square. Or I can write down a square plus b square to the power 1 by 2. Now there is another under root. So another under root is being used. So under root a square plus b square to the power 1 by 2. Can I write it down as a square plus b square to the power 1 by 4? In the calculation I will be using it. That's why we are dealing it here. Now what is the angle? Since there is an under root, so I will get 1 by 2. If there is the power 1 by 2, a plus iota b to the power 1 by 2. So if I need to write down the angle, then I will put it ahead 1 by 2 tan inverse b by a. Is that clear to you? Okay. What will be the magnitude for this? So 1 by under root is there, a square plus b square 1 by 2, right? So that will be 1 by a square plus b square to the power 1 by 4. And if I need to write down the angle, what will be the angle? Since there is 1 by, so minus sign. Since there is under root, so 1 by 2. Then tan inverse b by a. Did you understand? If there is under root, then 1 by 2. Tan inverse b by a. Since there is 1 by something, so minus sign is also there. 1 by something, so minus sign is also there. Is that clear to you or not? Even if you did not know it, now you have understood. So how I can write down this value? That is the magnitude of neta 1 upon a square plus b square to the power 1 by 4. And then the angle, that will be exponential j to the power minus 1 by 2 tan inverse b by a. So this is how this quantity can be written. This complex number 1 upon root a plus iota beta can be written like this. Is that clear to you? Same goes for these one as well. Okay, so we will be using this when we study about intrinsic impedance. That's why we are dealing it here. So there you should not have any doubt. Now let's start our derivation. So we are going to analyze EM wave in free space. So now our derivation will start. So we have seen all the prerequisite. Let's revise it again, whatever that we have seen. So first I had the direction of A, then I wanted to calculate del cross A. Then I had the direction of A, then I had the direction of del cross A, then I wanted to see what is the direction of A. I go to know that A and del cross A are perpendicular to each other. Same goes here, del cross E minus del B by del T. So from there we saw some good question that if that is the direction of B, then this is the direction of E. And if this is the direction of E, then this is the direction of H. So H is perpendicular to E, E is perpendicular to H. Then if we see it intuitively, this is the current, this is H. If this is S, this is E. If this is E, this is H. If this is H, so if this is E, this is H. If this is E, then other one H. EH both are traveling in Z direction. Okay. So E, H and propagation all are perpendicular to each other. Also we got to know that direction of E into direction of H is equals to the direction of propagation. Right? Direction of E into direction of E cross direction of H is equals to direction of propagation. Again we will see it, but for now you will remember it. E cross H is equals to P. This is what you are going to remember. E cross H is equals to P. So this is how we saw the EM wave going. Then we needed to derive it, but from here only we got the expression without even doing any mathematical calculation. Now our target will be to derive this expression only. Okay, now our target is to derive this expression only. So how we are going to derive that we are going to see. Okay, but without even doing any calculation we derived it. How did we derive it? Because I know this is a time harmonic vector field, because it is a function of space, function of time, and it is periodic as well. And for time harmonic vector field, I know how to write down the expression. E to the power minus j beta z, e to the power j omega t. Then real part I can take, imaginary part I will take. For analysis purpose, I will always take the real part. Okay. Then lossless and lossy medium. Then we study about conductive and dielectric. This slide might be a bit confusing to you, but you don't need to mug it up. You will be eventually remembering it. Conductive means it will have some conductivity. Sigma will not be 0. Ideally for dielectric, sigma should be 0. For dielectric medium, sigma should be 0. But there will be a case if it is a lossy dielectric. If there is some loss, then certainly sigma will not be equals to 0. Like there will be some value of sigma, but that would be low. But that value of sigma will be low. So that will be lossy dielectric. This is lossless dielectric, conductive. These things will come again and you are going to remember it. From this slide, you just need to know that there will be linear, isotropic and homogeneous medium. Linear is D varies with E linearly. Same goes for B and H. Same goes for J and E. Isotropic means epsilon will be same in all the direction, and homogeneous means epsilon, mu and sigma will not be a function of space coordinate. Okay. Then we saw this thing. Then this was the conclusion. And then we saw some mathematics. That Laplacian is actually performed on scalar only. If we are performing it on scalar, then we will perform it on AX component, AY component and AZ component. Then we saw the polar form. Now we are going to do the mathematical calculation of EM wave in free space. So this is our first one. So we are going to see it in free space. Okay. Then we are going to see it in lossless dielectric. Then we are going to see it in lossy dielectric. Then we are going to see it in conductor. So there will be 4: free space, lossless dielectric, lossy dielectric, and conductor. So in 4 we are going to analyze. First one is free space. So a free space is always our medium will be linear, isotropic and homogeneous medium. It is charge free as well. In the space there is charge, but collectively it is 0. Positive charge and negative charge cancels out. So we may call it charge free. Charge free means it doesn't mean that there are no charge. There is positive charge as well, there is negative charge as well. But collectively the whole charge is 0. So volume charge density is equal to 0. And certainly in the air there is no current. Like if I put my hand here, am I getting some current here? No. So it is non-conductive as well. So sigma is equal to 0. For free space, epsilon is equal to epsilon naught and mu is equal to mu naught. Basically, epsilon are relative permittivity and relative permeability. Both are equal to 1. Okay. So these are the things. So how will my Maxwell's equation change now? So del cross ES. Always we are going to write down Maxwell's equation in phasor form. We are going to do the calculation in phasor form. Once we get the final answer, we will add e to the power j omega t and take the real part after it. Is that clear? So we will do the analysis in phasor form. So now how I can replace it? J omega, in place of mu, can I write down mu naught? Yes. H of s. Sigma will be 0. So this term will be gone. So j omega, in place of epsilon, can I write down epsilon naught? Yes. Rho v is 0 and this is already 0. So what all are the equation? Del cross minus sign is there. Del cross ES is equal to minus j omega mu naught h of s. Del cross hs is equal to j omega epsilon naught ES, and del dot d is equal to 0. Del dot b is equal to 0. So now we are going to solve this equation and we will get our electric field and magnetic field expression. So we will see it, but I will take a break, and after that we will see it. You can also drink some water. Okay, then we will start. Yeah, welcome to the second half of this video. Now we are going to derive the mathematical equation. But before starting the derivation, let me tell a few things. So the question would be, is that important for your GATE examination? Is the derivation important for your GATE examination? So the answer is no. The derivation is not important. But as a GATE aspirant, should I ignore the derivation? Again, the answer is no. You cannot ignore the derivation. Just see it once. When you revise the notes, at that time you can ignore the derivation. Okay, what I am saying, now I will explain. Now I will be explaining you the derivation. So at that time you can see the derivation. When you revise the notes, at that time you can ignore it. So during the derivation we will make some assumption. So those assumptions you should need to know that what assumptions you are making. So if you know the assumptions, then the derivation will come to you in their own way. So just see the derivation once, and after that you can ignore it. So whatever the results we are going to get from the derivation, those results are important for you. So let's start now. So these are the equation we are having. This equation 1, 2, 3, 4. These are our equation for free space. We are deriving for free space. So del cross E is equals to minus j omega mu naught hs. Now if I take curl on both of the side, so I can take curl on both of the side. So here minus j omega mu naught. These are not the function of space. Why they are not the function of space? Because our medium is what? Linear, isotropic and homogeneous medium. Also it is charge free and non-conducting. So they are certainly not the function of space. They are homogeneous, so they are not the function of space. So I can take del cross hs here. If I am taking del cross hs here, what is the value of del cross hs? From this equation 2, I can get j omega epsilon naught es. So simply I am putting the value. Now what is the value of del cross es? Have I taught you this? Yes. The value will be del dot e into del minus del square es. Right? What is the value of del dot e? What is the value of del dot e? That is 0. Del dot e is 0. So del dot e is 0. So from here this is something you are getting, and from here this is something you are getting, because j and j will make minus 1. J square is minus 1. I hope you know it. J square is minus 1. Minus 1 into minus 1 will be 1. And from here you will get omega square mu naught epsilon naught es. Simple mathematics we are doing. Okay. So which formula we have used here? Del cross hs is equals to j omega epsilon naught es. This is what we have used. Also what we have used, del dot es is equals to 0. So from here this is the equation we are getting, minus del square es omega square mu naught epsilon naught es. Omega square mu naught epsilon naught, I can put this equals to beta square. What I am putting? Your beta square is equals to omega square mu naught epsilon naught. So from here what is the value of beta you are getting? Omega under root mu naught epsilon naught for free space. So this is something important formula we have got. This is the value of beta. So this is something you need to remember from the derivation. This is for free space only. For different medium it would be different. So that we are going to see in the later part of the video or in the next video. But beta for the free space, what you have got, this you need to remember. Beta equals to omega mu naught epsilon naught. You can write down in your notebook. Beta equals to omega mu naught epsilon naught. So del square es is equals to minus beta square es. This is known as vector Helmholtz equation. Okay. This is something that is a tough name to call, vector Helmholtz equation. Vector Helmholtz equation. Okay. So this is the vector Helmholtz equation that we have got. Del square es minus is equals to minus beta square es, where beta is omega under root mu naught epsilon naught. So this is something that you need to remember till now. Now we are going to solve this equation. So this is your Laplacian operator. Del square es, this is your Laplacian operator. Did I tell you how to solve this? Yes. So what we are going to write, del square es is equals to minus beta square es. Now your es is, now what is es? Es is the phasor representation of the electric field. So electric field can be in x direction, in y direction and in z direction. Electric field can be x direction, y direction and in z direction. Okay, so exs ax cap plus eys ay cap plus ez az cap. Now one assumption I am making, what is that? That my EM wave is traveling in positive z direction. This is the assumption I am making, that my EM wave is traveling in positive z direction. Now let me know one thing. If your EM wave is traveling in positive z direction, this is positive z, this is x, this is y. If it is traveling in positive z direction, then your electric field component can be in x direction. Electric field component can be in x direction. It can be in y direction as well, but it will never be in z direction. Look, let's get back to the initial part from where we started our everything. From here we started. So here our electric field component was in x direction, right? It was in minus x as well. If I had taken the slope, let's just say at this point, then this is your x direction. Where will be my electric field? My electric field will be in this direction. So my electric field could be in y direction as well. My electric field can be in x direction, my electric field can be in y direction as well. But if it is propagating in z direction, then certainly there will be no component of electric field in z direction. Is that clear to you? What I am saying, if my electric field is propagating in z direction, then the component of electric field will be in x direction or in y direction. It can never be in the direction of z. What do you mean by that? That az cap, whatever that is written here, that would be 0. If I have written azs here, so this azs will be 0. Is that clear to you or not? If I am assuming that my wave is traveling in z direction, that means there will be no component of electric field in the z direction. Like this can be my electric field, 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 but my electric field component can never be here. Is that clear to you? Yes. So let's get back to our derivation and what we can conclude from that. So what did I say? Assuming EM wave is traveling in z direction, then EZS will be equals to 0. Is that clear to you? This is a very important point of the derivation, and a lot of places this point is taught wrong. Now I hope it is clear that if it is traveling in z direction, then x component could be there, y component could be there, but z component cannot be there. The second point, E and H will be function of z. What do I mean to say? That component will be in AX cap or in AY cap, but where it is traveling? It is traveling in z direction, so it will be function of z only. Look, if my wave is traveling in z direction, that means with respect to z coordinate it is changing. With respect to z coordinate it is changing its magnitude. If my wave is traveling in z direction, that means that with respect to z coordinate it is changing its magnitude. At z equals to something else, it will have some different magnitude. At z equals to lambda by 2, it will have different magnitude. At z equals to lambda by 4, it will have different magnitude. But it is changing its magnitude with respect to z. Say yes or no. Is that correct to you? Yes. Just a second, someone is at the door. I will come. Yeah, sorry for the interruption. So what I was saying, the E and H component will be a function of z. The component is in x direction and y direction, but it is traveling in z direction. The field is traveling in z direction. You will have AX component, you will have AY component, right? And it will be a function of z because with respect to z coordinate, it is changing its magnitude. Is that clear to you? So E and H will be a function of z. So this EXS, what do I mean to say by that? That is, this EXS which is non-zero, that will be a function of z. This EYS which is non-zero, that will be a function of z. It could be a different function. So g of z I am writing. So they will be a function of z. Okay. Now what I am saying, E and H field will be in AXY cap and AY cap direction and function of z in space. Is that clear to you? So electric field can be written as EX AX cap plus EYS AY cap. So from equation 1 what I am getting, del square EXX AX cap plus del square EYS AY cap is equals to minus beta square EXX AX cap plus EYS AY cap. Basically electric field, the phasor representation of electric field has been reduced because this has went to 0. So I am just putting these values, del square this. Now if I compare, what I am getting, del square EXS minus beta square EXS and del square EYS is equals to minus beta square EYS. Both equations are same. Del square EXX minus beta square EXX is del square EYS minus beta square EYS. Both equations are same. So I can solve only one equation. Both equations are same. That means I can solve only one equation. Is that clear to you? So I will solve only one equation. So electric field can be in the direction of AX cap as well, in AY cap as well. So both will be zero. Both will be non-zero. That EXS is also non-zero. EYS is also non-zero. And both are function of z. They will be non-zero. But for the derivation purpose, I am only considering E field in x direction. Look, E field can be in x direction as well, E field can be in y direction as well, and it will be traveling in z direction. X and y traveling in z direction, but for derivation purpose, I am only taking this in action. Okay, because both equations are same. If I have solved this equation, then anyway I can write down the answer of this equation as well. Say yes or no? Okay, I have the EM wave, I am writing down the equation of that EM wave. So that EM wave is traveling like this. So this is your electric field, but electric field can be in y direction as well, x direction as well, y direction as well. But I am only solving for this, I am not solving for this. If I solve for this, then I can write down this expression very easily, right? Okay, so this is I am considering that electric field is only in x direction, but the function of z in space. So if this is a function of z, exs is a function of z. So if I calculate del square exs, so what I will do, del square del x square exs z, del square del y square exs z. Why I am writing z? Because it is a function of z, right? That's why I am writing it as exs z, because it is a function of z. So exs z plus del square by del z square exz. So let me know what will be the value of this. 0. Why? Because what you are doing, del square del x square. Now it is a function of z. I don't know the expression, but I actually know the expression. It will be E naught cos omega t minus beta z. If we are deriving, then we don't know, but we already know the answer because we have intuitively seen it. So it will be something like this. So you are differentiating with respect to x and the function is of z. What will be the answer? 0. Same goes for y. This will also be 0, but this will be non-zero. So your del square exs, is coming out to be this. Okay, is everything is clear? This is the whole correct derivation. Okay, there are a lot of wrong things, even in the textbook you will find a lot of wrong things about this derivation, but this is the correct one. Which all assumption we have made till now, that our field is traveling in z direction. If field is traveling in z direction, that means az cap component will not be there. That means electric field cannot have any component in az direction. But since it is traveling in az direction, then exs and eys will be a function of z only, right? Now from there we are getting two equations. Both equations are same, so I am gonna solve only one equation. Okay, so I am gonna solve only one equation. From there I go to know that del square by del x square is 0. This is 0. This is 0. This will be non-zero because electric field is a function of z. So this is what I am getting. Now I will put this value equal to this value, right? So what I am gonna do, this is what I am gonna put. So these two are equivalent. From equation 2, this is my equation 2. Where is the equation 2? This is the equation 2. So from equation 2, this is what I am putting. So if I take this on this side, so this is a second order differential equation. Do you know how to solve it? So this I can take as m square. So m square plus beta square exz is equals to 0. So from here if I solve it, what do I get? M equals to plus minus j beta. Okay, m equals to plus minus j beta. So what will be the solution of this equation? There could be three solutions. What all are the roots? Plus j beta and minus j beta. So what could be the answer? Some constant e to the power minus j beta z, or some constant e to the power plus j beta z, or linear combination of both of them, or simply the addition of both of them. So these two answers are possible. What does this say? That electric field is traveling in positive z direction. Do you remember omega t minus beta z? If there is minus beta z in phase, that means it is traveling in positive z direction. What it is saying? It is traveling in negative z direction. What it is saying? What this expression is saying? It is traveling in positive z as well, it is traveling in negative z as well. Ideally, it will travel in positive z as well, it will travel in negative z as well. Because here only I told you that here also there could be component, so it can travel here as well. It will generate, then again, so in this direction as well it can propagate. But again, what did I tell you? We will always take one dimensional motion. When we are deriving, we will always take one dimensional motion, because that will be easy for us to analyze. Like whatever the equation you are going to get, we are going to analyze that equation, right? So there are three possible answers of this particular equation, that E naught e to the power minus j beta z, E naught dash e to the power j beta z, or this answer or this answer. But we will take this answer in action. Why we are taking this answer in action? Because we will only see one dimensional motion. Here wave is traveling. Wave is not traveling in this direction. On this direction only wave is traveling. So this is what we are going to take. So assuming wave is traveling in positive z direction. So this is the third assumption we are making. First assumption was it is traveling in z direction. Second assumption was we are solving only one equation. That means we are not considering EYS component. What was the second assumption? Here we are not considering this particular component. We are only considering this component. So with respect to only one component we are solving. Okay. So this is the phasor representation I am having. Now I have got the phasor representation of electric field. Along with this phasor component, I should have put Ax cap as well. Why Ax cap? Why I am putting Ax cap? Because basically this EXS I have got. EXS I have got. And what is my electric field? This is my electric field. EXS I have got. What is my electric field? My electric field is EXX AX cap, EYS AY cap, EZS AZ cap. This is by default 0. And this is I am assuming 0. This I am assuming 0 because I am not considering this. So what will be my electric field? EXS AX cap. So EXS I have got. AX cap I will add. So as of now I am not adding it. EXS I have got. EXS I have got. So forget about AX cap. So if this is the phasor representation and you need to go to time harmonic vector field, how you can go there? You know electric field is a time harmonic vector field because it is periodic in time, it is function of space as well, and if it is periodic then it will be time harmonic vector field. So what you are going to do, you are going to add e to the power j omega t. So if I add e to the power j omega t directly, I can take real part as well, I can take imaginary part as well. But which answer I will take? Always I will only analyze the real part. So what is the answer? E naught cos omega t minus beta z. Right? Real part of e to the power minus j beta z, e to the power j omega t. This we have already seen, right? This will be the answer. Cos omega t minus beta z. In some problems, they can give sinusoid as well. In some problems, they can give exponential as well. So don't get confused there. We can have three possible answers. They are taking the real one. We are taking the real one. In some problems, you can find the, which you can find? You can find your sinusoidal as well or complex exponential as well. So there you will not be getting confused that, sir, what they are asking. Okay, is that clear to you? Is the derivation clear to you? That's why I said derivation is important because we are getting to know a lot of things. We actually studied it is E naught cos omega t minus beta z, but there are a lot of assumption involved behind this. What all are the assumption? That here we are taking real part. It is traveling in positive z direction and we are not considering the z component. These are the assumptions. Okay, so we are going to write down the assumption one by one. So this is the EM wave electric field expression we are getting. This is the electric field expression we are getting, which is E naught cos omega t minus beta z Ax cap. So it is traveling in z direction, but with respect to x, it is changing its magnitude. Basically, it is changing its magnitude with respect to z coordinate, but it has the direction of Ax cap. So here your magnitude is E naught Ax cap. Here your magnitude is E naught by root 2 Ax cap. Here your magnitude is 0. So this we have already seen in the previous video. Have you seen the analysis of this particular expression? Yes, every single analysis we have seen. Now we have derived the electric field expression. But with respect to that electric field, we will have a magnetic field as well. Right? We have solved only for electric field. There will be some magnetic field as well. So first we are going to solve the expression of magnetic field in phasor form. So what we have? Del cross Es is equals to minus j omega mu naught Hs. So from here we can get the value of Hs. How we will get? First calculate del cross Es because you are having the expression of Es. You are having the expression of Es. Right? Use the expression of Es, get the value of Hs from there. So this is what we are going to do. Are you having the expression of Es? Yes, this was the expression of Es. E naught e to the power minus j beta z Ax cap. E naught e to the power minus j beta z Ax cap direction also I am putting. So what will be your Hs? Hs will be del cross Es divided by j omega mu naught. Simply this comes here, minus sign also comes here. So now I need to calculate del cross Es. What will be del cross Es? So directly you can see from here, Ax cap component will be 0, Ay component you will get. So what will be your Ay component? That will be, Ay component will be del by del z of this particular value. That will be minus j beta E naught e to the power, this is z not x, e to the power minus j beta z. So this I am doing, I am just doing the differentiation of this. So e to the power minus j beta z az ay cap basically what you will do, Ax cap you will do, then 0 0. Then what you are going to do, Ay cap you are going to do. So the differentiation of this, that will be this, and differentiation of this will be 0, right? This is how we solve it. Then Az cap you are going to do 0 0. So this is the final answer you are getting. That is the answer of del cross Es. Again, in a better manner I am going to write it. That is minus j beta E naught e to the power minus j beta z. So this is the expression of del cross Es I am getting. So what is your Hs? Minus sign, again minus sign, del cross Es I am going to put, and then j omega mu naught I am going to put. So basically I am just going to put the expression. So from here this is the expression of Hs you are getting. How you are getting it? How you are getting this expression? Del cross Es value minus j beta E naught e to the power minus j beta z, and then j omega mu naught, and minus sign is also there. So minus minus get cancelled, j and j get cancelled. So beta E naught upon mu omega naught, sorry, omega mu naught, beta E naught upon omega mu naught e to the power minus j beta z. You don't need to remember these expression, okay? I am not telling anything to remember, just see the derivation and forget it. Just see the derivation and forget it. Whatever that you need to remember, that I am going to tell. Do not worry about that. So what you are getting here? Hs equals to beta E naught upon omega mu naught e to the power minus j beta z Ay cap. So this is the phasor representation. So from phasor to time domain representation, if you are going, then what you are going to do? You are going to add e to the power j omega t and take the real part. So this is what I have done, right? So this is what I have done. So from here I am going to get the time harmonic vector field. So I am going to write time harmonic vector field. So from phasor representation, how you can get time harmonic vector field? You add e to the power j omega t and then take that real part. So that's why I said the previous video was very important. And this magnitude I am putting as h naught. So h naught is equals to beta E naught upon omega mu naught. Do you need to mug it up? No. Am I asking you to mug it up? No. Just see it and forget it. So this is what I am getting. So what was the direction of E field? The direction of E field was Ex cap. With respect to the direction of E field, what is the direction of H field? What I am saying, if your direction of E field is Ex cap, then what is the direction of Y you are getting? Sorry, what is the direction of H you are getting? Ay cap. Ay cap. And what is the direction of propagation you are getting? Az cap. So from here what I am getting to know. Say yes or no. Now tell me one thing, if my direction of propagation of E field was Ay cap and my direction of propagation of H field was Az cap, so in which direction my EM wave will be propagating? This is the question for you. If my direction of propagation is, if my direction of electric field is Ay cap and direction of magnetic field is Az cap, then in which direction my EM wave will be propagating? Ey cross Az. What that would be? Ax cap. So my field will be propagating in Ax cap direction, right? Now I am going to write down more expression. So what I am assuming, the field is going in z direction only. Sorry, the EM wave is going in z direction. What I am saying, EM wave is in positive z direction only. The direction of EM wave is positive z. Now what did I say? Here I said that there will be two components, x component as well, y component as well. But I solved for x component only. But certainly there will be y component as well. Like E, Y, S, Ay cap will also be non-zero. So electric field will be there in y component as well. So if I assume my electric field is y component, if I assume that my electric field is in Ay cap, then where will be my H field, considering that my wave is propagating in positive z direction only? Did you understand my question? That my electric field is in Ay direction. My electric field is in y direction. In which direction I will have my magnetic field, considering that my propagation direction is Az cap only. Is that clear to you? When electric field was in x direction, my magnetic field was in z direction. Sorry, if electric field was in x direction, my magnetic field was in y direction. So x cross y, wave was propagating in z direction. Now my electric field is in y direction. My electric field is in y direction. In which direction H has to be there so that the propagation is in z direction? This is my question. Is that clear to you? This is very easy, right? So let's try to get the expression of a magnetic field. Look, you can get this expression by solving the equation as well. How will you get this expression? By this formula, right? You write down del cross Es upon j omega mu naught. Del cross Es you can calculate from here. Del cross Es. Del cross Es. You get the phasor form of this. You calculate del cross Es. Then you divide by j omega mu naught. Divide by j omega mu naught. You will get the expression of Hs. Once you get the expression of Hs, from there you can get H by Zt. But one thing I know, that if the direction of propagation is Az cap, then that will be equals to the direction of electric field, which is Ay cap, into direction of the magnetic field. So what will be this value? So y cross x will give me minus z. X, y and z. So what do I know? That x cross y give me z. So y cross x will give me minus z. X cross y will give me z. Y cross x will give me minus z. But I need plus z. So what I should add? Minus ax cap. Y cross x will give me minus az cap. And another minus sign is there. So minus minus get cancelled. What you are getting? Az cap only. So what will be the direction of magnetic field? That will be minus ax cap. This is how you will get the direction of the third. If you know the direction of electric field, if you know the direction of wave propagation, can you let me know the direction of magnetic field? Yes, sir. What I am saying, if you know the direction of electric field, if you know the direction of if you know the direction of electric field, if you know the direction of wave propagation, can you let me know the direction of magnetic field? Yes, sir. Az cap is equals to Ay cap cross something. So what something I need to put? I know y cross x will give me minus z. Y cross x will give me minus z. X cross y will give you plus z. Y cross x will give me minus z. So I need to put another minus sign to get Az cap. If this was plus here, then in which direction it is traveling? Minus Az cap. So do you need to put another minus sign here? No. Then your answer would have been Ax cap. But here there is no plus sign. So now EM wave is traveling in positive z direction. If EM wave is traveling in positive z direction, electric field is in y z direction, then your magnetic field will be in, where magnetic field will be there? In minus Ax cap. So H naught cos omega t minus beta z minus Ax cap. Did you understand this point or not? A very important point. A lot of questions are asked on this particular concept only, but very simple as well. What is the concept? The concept is direction of propagation is equals to direction of electric field cross direction of magnetic field. That's it. So direction of electric field is Ay cap, cross direction of magnetic field is minus Ax cap. Ay cross Ax will give you minus Az, and another minus sign is there. So what you are going to get? Az cap. So direction of propagation is in z direction. Yes, it is in positive z direction. Is that clear? Okay. So this is how you are going to solve these problems. I hope it is clear to you. I hope you are able to visualize everything. So this diagram we made. Which diagram we made? This diagram we made. Here we saw that there is one component of E, there is one component of H. But in actual, there will be another component of E. There will be another component of H. Are you getting this point? When we study EM wave, we study only one dimensional motion, that E is dancing around X only. Here what did we assume? That E is dancing around X only. That's why we got our expression in Ax cap. But in actual, if it is dancing in X, it will be dancing in Y as well. But in 99% of the chance, you will get only one dimensional motion. But in the examination, if your electric field is written something like this, that E naught cos omega t minus beta z Ax cap plus E naught cos omega t minus beta z Ay cap. If your electric field is written like this, then you should not be getting confused. Why is that so? Because we have seen the derivation. In the derivation, we got to know that it can be in x direction as well, it can be in y direction as well. But when we study EM wave, for studying it, we consider only one dimensional motion, that my electric field will be dancing in x direction only. This is what we assume. And my magnetic field will be dancing in y direction only. This is what we assume, if my wave is traveling in z direction. But if in the examination, if you get some expression like this, then what will you understand? That there is some electric field in x direction, there is some electric field in y direction. So with respect to this electric field, there will be some magnetic field. and with respect to this electric field there will be some magnetic field. What will be the direction of that magnetic field? If wave is traveling in positive z, so what you need? Y cross x will give you minus z, so that will be minus Ex cap, right? With respect to this electric field, can I write down the magnetic field? Yes, Ex cap. So magnetic field will be in Ay because it is traveling in positive z direction. And if it is again traveling in positive z direction, that means with respect to electric field which is in y, so H has to be in minus x, because Ay cross minus Ax, Ay cross minus Ax is plus Az, y cross s is y cross x is minus z, so minus minus plus, right? So I hope that is clear, which is a typical point which we have understood. And another interesting point which we have understood is that here we assumed only one dimensional motion, that electric field is dancing in x direction, electric field is dancing in y direction. But actually electric field can dance both in x as well, both in y as well. So let me know one thing, if it is dancing in x as well, if it is dancing in y as well, so resultantly where it will dance? Somewhere here, right? It is dancing in x as well, it is dancing in y as well. So resultantly where it will dance? This is vector Ex cap, this is vector Ey cap. So resultantly it will dance here. Are you getting this point? Now are you having this doubt that sir, this resultant component is not perpendicular to the direction of propagation? Are you having this doubt now? That sir, you said that electric field can dance in x direction as well, it can dance in y direction as well. So are you having this doubt that sir, now this resultant component is not perpendicular to the direction of propagation? Are you having this doubt now? No, that is incorrect. You feel like that it is not perpendicular to the direction of propagation, but it is perpendicular. Why is that so? Electric field is dancing in Ex cap, electric field is dancing in Ay cap. What will be the resultant? This will be the resultant. Isn't it perpendicular to Az cap? X, Y. Resultant will be in xy plane only, no? And certainly Z will be perpendicular to xy plane. X, Y. X, Y. Resultant will be on this plane only. And field is and EM wave is traveling like this. So certainly it is perpendicular only, you know. Like when I studied this topic for the first time, there I got this doubt that x is there, y is there, so resultantly it should not be perpendicular, but actually it is perpendicular, because you are seeing it in 2D. If you see this plane, if you see this plane, the perpendicular plane, it is perpendicular to z only, you know. This is perpendicular to z, right? So yes, this doubt some people can have, and we are going to study about this in detail when we study polarization. So I am just building up your concept, because there a lot of people get confused in polarization, that what is actually happening, and no one will give you this visualization, I can tell you, okay? And I am not praising myself, it's your job. Like if you found this content helpful, then it's your job to praise me. But I am just telling that what kind of depth you are understanding here. You are actually able to visualize the electric field. EM wave is not all about formula. It is certainly about formula. We are going to learn the formula as well. But certainly it is about visualization as well. Like you ask 99 of the aspirants, they wouldn't even know that electric field has some associated y direction field as well. They wouldn't even know. Along with y direction, you will have something in minus y direction as well. They would, along with y, you will have something in x direction as well. They wouldn't even know this. They would think that if it is traveling in x, there will be only x component. They wouldn't even know the derivation correctly. The derivation says we assumed that y direction component is 0, but actually it is there. Okay, so in polarization we will get to know that, we will see the equivalent of it, and then we will plot it on a plane, that how it looks like. It may be linear, it may be circular, it may be ellipse. So based on that we study 3 polarization: linear, ellipse and circular. And did I give you the intuition of e to the power j theta? So the same kind of concept will be used there. So I will give you the visualization there, no doubt about that. Certainly I will give you the visualization, but just for your reference I am telling that this much depth you should be covering. So in the examination, if any expression is written there, you will not be getting confused that what is the meaning of this expression, and you will remember these things for a very long time if you study in this manner. Like if you study in this manner, it will certainly take some time to study, but once you have studied it, you will remember it forever. Forever you are going to remember, because you have seen the electric field in your brain, you have seen the magnetic field in your brain, you have seen the motion of EM wave in your brain. So you are going to remember it. I hope this derivation is clear. I hope every assumption is clear. And I hope all the expression that we have got, that is also clear. And I hope this direction is also clear. The direction of here, the direction of propagation is in Z. This was in Y. So what should be the direction of magnetic field? That is minus Ax cap. Is that clear to you? And what all the assumption we have made? That wave is traveling in positive Z direction. Now E field and H field can be present both in Ax cap as well, in Ay cap as well. But basically both would be there. Axs is also non-zero, Eys is also non-zero, Hxs is also non-zero, Hys is also non-zero. Okay, here what I should write? Hx. So here what you are getting? Hx Ey, Hx Ey, and previously what you were getting? Hy Ex, Hy and Ex, Hy and Ex. So Hy and Ex, Hy and Ex. All component will be 0, but at a time we are only considering one component. So for E component we consider in Ax cap direction. So for the first expression we got was this, and with respect to that we got our H field expression, which was in Y cap, Then we saw that there was one Y component as well for electric field, which was this. So with respect to that there will be one component of magnetic field in minus Ax cap, but expressions will be given as E naught cos omega t minus beta z Ax cap. Only one dimensional motion they will take. Okay, so this is the motion that we have studied already. Let's see some key properties. So let me take a break, then I will teach the property. So let's start the key properties. So EM waves are known as transverse electromagnetic wave, and in short form we call it TEM wave. So why do we call it TEM wave, transverse electromagnetic wave? Why do we call it that? So transverse means perpendicular. So here electric field, magnetic field and the direction of propagation all are perpendicular to each other. What do I mean to say is that if this is your electric field, if this is your magnetic field, then this will be your direction of propagation. Are you getting this point? So all are perpendicular to each other, that's why it is known as transverse electromagnetic wave. P means direction of propagation. And the second thing we know is that if the direction of electric field is AE cap and the direction of magnetic field is AH cap, then what will be the direction of propagation? Direction of propagation is known as P is equals to A cross H. This is what you need to remember. P is equals to E cross H. Right? Now, these 2 points are true for any medium. Okay? These 2 points are true for any medium, whether it is free space, whether it is conductive, whether it is dielectric or lossy dielectric, lossless dielectric. It is true for everyone. Is that clear to you? Now we are going to see for free space only, because this equation we have derived for free space. These equations we have derived for free space, not for a general medium. So only for free space we are going to see now. So for free space, what is the phase difference between E and H? What is the phase difference? This is known as phase. So both are at the same phase, or in the graphical representation also you can see. Here there is a clearer diagram. So you can see that this line and this line are in same phase, this line and this line are in same phase. That means when they are traveling together. Like it's not that E field is ahead, H field is ahead, E field is lagging behind or H field is leading. So there is nothing like that. All are traveling together. This guy and this guy are traveling together. They will have the peak at the same time. This is having the peak, this guy is also having the peak. So peak is also at the same time. So there is no phase difference. Also by the expression also you can see. Like if there was some phase difference, then it would be written like this: cos omega t minus beta z minus some phase. Some phase should be there. Here phase is same. So phase of E and H are same. This is what I have written. Can you tell me the formula of phase constant beta? 2 pi by lambda, that we already know. In the last lecture only we studied it, 2 pi by lambda. But one more formula we got out. This is the formula we got. Where is the formula? Too long derivation. This is the formula. Omega mu naught epsilon naught. Right? So derivation again and again you do not need to remember. But from here we got a very important result. What is that? So second formula I am gonna write. Beta is equals to omega mu naught epsilon naught, but this is applicable only for free space. Remember that everything we are going to write down only for free space. So from now onwards everything is written for free space, not a general medium. For a general medium also we will write, but to understand the EM wave first we need to understand it for free space. What is the time period? 2 pi by omega. Time period is 2 pi by omega, right? Omega will be given, so time period you can find 2 pi by omega. Time period of EM wave, with which time period it is traveling. Velocity, how velocity is defined? Velocity is defined as Vp equals to, phase velocity we are calculating, Vp equals to omega by beta. What is the value of beta? This is the value of beta. For free space, only for free space we are writing. Vp equals to omega by beta, this formula we have seen in the last lecture. Omega by beta, beta value is omega under root mu naught epsilon naught. So what you are getting? 1 upon mu naught epsilon naught. So first thing you will see this, that Vp is equals to, here I am gonna write Vp is equals to 1 upon mu naught and epsilon naught. So this is something you need to keep in mind for free space. Also one thing you know, that mu naught is constant. What is that? 4 pi into 10 to the power minus 7, and epsilon naught is also constant. What is that? You can write down 8.85 into 10 to the power minus 12, right? This you can write down. So if you do this calculation, and you put 1 by under root, because this is a constant value, no? Mu naught is constant, epsilon naught is constant, under root is there, so this is a constant value. So what you are going to get? Vp equals to, once you solve this, you are going to get Vp equals to 3 into 10 to the power 8 meter per second. So this is the answer. Okay, so it is a constant velocity which is equals to the speed of light, 3 into 10 to the power 8 meter per second. Okay, 3 into 10 to the power 8 meter per second. So this you need to remember. In free space, EM wave travels with the speed of light. In free space, EM wave travels with the 3 into 10 to the power 8 meter per second speed. With this speed it travels. And what is the graphical representation that we have seen 3 times? This is the graphical representation. What is E, what is H? We have already seen. This is your E, this is your H, and this is your propagation. Okay. Now there is some term called intrinsic impedance, very important term. Okay. So what is the meaning of intrinsic impedance? Intrinsic impedance is the ratio of phasor representation of electric field. Ratio of phasor representation of electric field, phasor of electric field to the phasor of magnetic field. A lot of places they will say that it is the ratio of the magnitude of electric field to the magnitude of, ratio of magnetic field, ratio of electric field to the magnetic field, and they will talk about amplitude, but no, that is wrong. It is the ratio of the phasor representation of electric field to the phasor representation of magnetic field. Okay, so they are talking about the phasor here. So what is the phasor you are getting? What was the equation? E is equals to E naught cos omega t minus beta z. What will be the phasor of that? E naught e to the power minus j beta z. E naught e to the power minus j beta z, right? And what will be the phasor of H? H naught e to the power minus j beta z. So luckily this and this is getting cancelled, and your neta is coming out to be E naught by H naught. So here luckily you got the neta equals to, the ratio of their amplitude, but no, actual definition is it is the ratio of their phasor representation. So do remember this thing. A lot of times students get it wrong. So if some statement type of question is coming in the examination, they will say that neta is the ratio of the amplitude of electric field and magnetic field. That will be wrong. It is the ratio of the phasor representation of electric field to the magnetic field. Okay. Now this is the expression we are getting, neta equals to E naught by H naught. And for what we are calculating? For free space. For general medium also we will calculate, but as of now for understanding purpose we are calculating it for free space. So what you are getting? Neta equals to E naught by H naught. Do you remember what was your H naught? H naught was beta E naught by omega mu naught. That's why I told you do not remember it, because we will generate the expression of neta here. So what was your H naught? Beta E naught divided by omega mu naught. So our H naught was beta E naught divided by omega mu naught. No need to mug it up again, I am telling. So E naught divided by beta E naught and omega mu naught will go upward. Okay, so mu naught, E naught will get cancelled. What you are getting? Omega mu naught by beta, right? So this is one of the expression you can remember. One of the expression. Let me. We will come back. We will come to more expression. This is one of the expression which you can keep in mind, or you don't need to remember it. No need to remember it, because more shorter expression we are going to write, so that you can remember. Okay. So what is the value of beta? Beta is omega mu naught epsilon naught, right? This I asked you to remember. Beta is omega mu naught epsilon naught. Very important. So this and omega getting cancelled. So what is the expression you are getting? Mu naught epsilon naught, right? Omega and omega is getting cancelled. Here mu naught to the power 1, here mu naught to the power 1 by 2. So this will get cancelled. Under root mu naught you will get, under root epsilon naught you will get. So what is the answer of neta you are getting finally? Answer of neta you are getting is mu naught by epsilon naught. So this you can keep in mind. This is the expression for free space. Now these two are constant. Mu naught and epsilon naught both are constant. So what is the answer you can get? If you solve it, you are going to get 120 pi. And what will be the unit? Since it is impedance, so it will be ohm. So neta value for free space is 120 pi ohm. 120 pi ohm. And if you solve 120 pi, what do you get? 377. So neta value is fixed for free space. So neta value you are getting as 377 ohm. So these are the two expressions which you are getting. Very, very important. You highlight them. Okay. So for free space, neta is the ratio of the magnitude of electric field to the magnetic field. Only for free space. Otherwise, the general definition is this. It is the ratio of their phasor representation. But for free space, it is E naught by H naught. So in the examination, if they have given me the expression of E, can I find the expression of H? Yes. If it is a free space, the value of neta is 120 pi ohm or 377 ohm. This I will be remembering it. Then I can put 377 is equals to E naught by H naught. So I will have the value of E naught, I can get the value of H naught. So let's solve a numerical based on that. But so what I have written, for numerical purpose, we will use neta for finding the value of H from E or from E from H. So here expression of E is given. You need to find the expression of H. Also you need to find the value of beta and neta as well. So what is given? It is traveling in free space. We have already studied free space analysis. So what is the value of neta for that? Value of neta is 120 pi ohm, or you can say 377 ohm. This is the value of neta. What is the value of beta? From here beta I cannot get, right? But one thing I know, beta is equals to, what do I know? Vp equals to omega by beta. Vp equals to omega by beta. This is something that I know, right? Vp equals to omega by beta. Do you know the value of omega? Yes. Cos omega t. So omega is 10 to the power 8 radian per meter. Okay. So it is 10 to the power 8 radian per meter, which is your omega. Radian per meter, sorry. Radian per second, really sorry. It is radian per second, not radian per meter. Really sorry for the error. Yeah. So what is Vp for free space? For free space, Vp is equals to 3 into 10 to the power 8 meter per second. This is what I told you. In free space, EM wave travels with the speed of light. So 3 into 10 to the power 8. So here I can put 3 into 10 to the power 8. Omega value is 10 to the power 8. Beta value I need to find out. So what is the value of beta you are getting? Value of beta is 1 by 3, right? Yeah, beta value is 1 by 3. What is the unit for that? Unit for this is radian per meter, because this angle has to be in radian. So this is in meters, so radian by meter, or you can see it from this as well, 2 pi by lambda. So this is your angle, radian, and this is your lambda, which is length, so radian per meter. So unit is radian by meter. So beta value equals to 1 by 3. Very easy. Neta value already you know, beta value you got to know, Vp equals to omega by beta. Vp I already know, which is 3 into 10 to the power 8. Omega here, from here I can see that it is 10 to the power 8. So from there I go to the value of beta. Is that clear? Okay. Now what do I need to find? I need to find h. Now what is the direction of propagation? What is the direction of propagation? In which direction EM wave is traveling? Plus x. Omega t minus beta z, both are having the opposite sign. If both are having the opposite sign, that means it is traveling in plus x direction. So it is traveling in plus x direction. What is the direction of electric field? Electric field is in z direction. The direction of electric field is z, but it is traveling in x direction. So what will be the direction of h? This is what you need to find. So what do I know? AP is equals to AE cross AH. Also what I will draw, AX cross AY will give me AZ, AZ cross AX will give me AY, AY cross AZ will give me AX, AX cross AY AZ, AY cross AZ AX, and AZ cross AX AY, right? So here it is AX cap, wave is traveling in x direction, positive x direction, right? AE cap is AZ cap, AE cap is AZ cap. So what will be the direction of H? So what do I know? That Z cross Y, Z cross Y will give me minus x, because Y cross Z gives me x, Y cross Z gives me x, so Z cross Y will give me minus x. So if I put here AY, if here I put AY cap, so answer will be minus AX cap. If I put Z cross Y will be minus x, so another minus I need to use, right? Z cross Y will give me minus AX cap. So another minus I have to use, so minus minus will get cancelled out, answer will be AX cap only. So what is the direction of AH? So from here you got to know that my AH cap is in minus AY direction. So this is something which I got to know. Now I need to find the magnitude of H naught as well. So what do I know? Neta is equals to E naught by H naught. So H naught will be equals to E naught by neta. E naught value is 50 and H naught, E naught value is 50, okay, and neta value is 125, okay. So this is the value of H naught. So you have the value of H naught, cos is there, same expression will be there, cos will be there, 10 to the power 8 minus beta value is also there. So can I write down the H expression now? H is traveling in y direction, sorry, H is traveling in x direction only, H is traveling in x direction, but the component is in y direction, okay. What is the magnitude? Same expression cos, there is no phase difference is also not there, omega value I know, beta value I know, and here I am gonna write minus AY cap, or I could have written AY cap here. What I could have written, AY cap would come here and the minus sign I can put forward. This is the expression of H. I hope you got to know how did I solve this numerical. So neta, Vp, beta value I got. Now this thing I know that P is equals to E cross H. So E is in Z direction, so H has to be in Y direction, right? Sorry, minus Y direction, because Z into Y would give me minus X. So another minus sign I need to use. So minus AY cap would come. Then I need to think about the magnitude. So for the free space, they have given free space here. For free space, I know one thing. What do I know? That neta is equals to E naught by H naught. They are just simply the ratio of their magnitude. And neta value I know for free space, that is 125. So from there I got the value of H naught, that is 50 by 125. So 50 by 125 cos 10 to the power 80 minus 1 by 3 x AY cap. This is the answer. Very easy, very straightforward, right? Now we are going to analyze the EM wave in lossless dielectric, okay? Dielectric medium is there, but it is lossless. What do you mean by lossless? If this was our EM wave and this is the medium, then after the medium as well, there will be same amplitude, right? There is no loss. And if there is no loss, that means conductivity is 0. We will always take charge-free region. Always we will take charge-free region. And certainly it is linear, homogeneous, and isotropic medium. For free space, epsilon was equals to epsilon naught, but here it will be epsilon naught epsilon r. Only in free space epsilon r value is 1. Rest all the medium will have some epsilon r, rest all the medium will have some mu naught mu r as well. Okay. In 95% of the problems, it will be written that the material medium is non-magnetic. Okay, for non-magnetic medium, the medium is non-magnetic. For non-magnetic medium, you will take mu r equals to 1. Okay, it will be written in most of the problems. Your medium will always be taken as non-magnetic. And if it is not mentioned and there is no way to find mu r value, then by default you can take mu r value equals to 1. By default mu r equals to 1 you can take. In most of the problems it will be written that it is the material is non-magnetic, so mu r value should be taken as 1. Okay. Now what will be the Maxwell's equation for lossless dielectric? It will be same as free space. What will be the only difference? The only difference will be mu will be replaced by mu naught mu r and epsilon will be replaced by epsilon naught epsilon r. Rest all the derivation will be same. So am I going to do the derivation again? No. For lossless dielectric, sigma is 0. Same for free space. Same for free space. Only epsilon value will change. So wherever you are getting epsilon naught or mu naught, there you are going to put epsilon and mu. Is that clear to you or not? Right? So what will be the expression of electric field? What I am considering, EM wave travels in positive z direction. This is the assumption I am making. Based on this assumption, what will be your electric field? If I am saying that EM wave is traveling in positive z direction and I am saying that I am having the electric field component in x direction. So can I write down the equation like this? E naught cos omega t minus beta z Ax cap. And what do I know? That AP is equals to AE cross AH. Two assumption I have made, that it is traveling in z direction and it is traveling in x direction. So where it should travel? Sorry, it is not traveling, it has the direction of Ax cap. So what will be the direction of AH? Where will be your magnetic field? In y direction. So AY cap. So Ax cross AY cap. So if you need to write down the expression of H, how will you write down? H naught cos omega t minus beta z AY cap. Right? And what will be your H naught value? You don't need to mug it up, but I remember it. So for free space it was beta E naught upon omega mu naught. But in place of mu naught I will only put mu. This you don't need to remember, just I am writing it down because I remember it, but you don't need to remember. Because you will remember the expression of neta. From the expression of neta you can get this value. Okay, so let's write down all the values. What will be your phase constant? So for phase constant for free space was mu naught epsilon naught. Beta equals to omega mu naught epsilon naught, but here it will be this, and certainly it is equals to 2 pi by lambda. Okay, so this you are gonna remember. Only changes are just you need to replace these values. Beta equals to omega mu naught epsilon mu epsilon. What will be your phase velocity? That is equals to omega by beta. This formula is always constant. This formula is always true. So omega by beta. Now beta value has changed. What is the value of beta? This is the value of beta. So what is the answer you are getting? This is the answer you are getting. So Vp is equals to what you are getting? 1 by mu epsilon. Now can I write down in this manner? 1 by mu naught mu r epsilon naught epsilon r. Certainly I can write down. So 1 by mu naught epsilon naught into mu r epsilon r. So what is the value of 1 by mu naught epsilon, 1 by under root mu naught epsilon naught? What is the value of that? Can you let me know the value of this? Yes, it is 10 into 10 to 3, sorry, 3 into 10 to the power 8 divided by mu r epsilon r. This is the phase velocity you are getting. Okay, so this is one formula. In the, like, you do not need to mug it up. In the examination you would know that Vp equals to omega by beta. And for lossless dielectric, what do you mean by what I am studying? Lossless dielectric. So you would know that for lossless dielectric only mu and epsilon will change. So beta equals to omega mu epsilon under root mu epsilon. Then 1 by mu epsilon, mu naught epsilon naught you will take out. Then directly you can write down this step. This calculation you can do in your brain only. That omega by beta 1 by mu naught mu 1 by under root mu naught epsilon naught 3 into 10 to the power 8 divided by mu r epsilon r. And mostly for non-magnetic medium Mostly this will be given, so mu r will be taken as 1. So what will be your expression of Vp? This is the general. This will work for all the lossless dielectric. But this is and do not worry about all these things that sir there are a lot of formula. No, there are not a lot of formula. We are going to solve a lot of questions on that, so you will have a good practice. Along with that, we will write down the summary as well. So for now, you just need to see the formula and just be happy that we have seen this formula and try to remember it. We will write down the summary, we will solve the problems as well. After that, everything will be clear. As of now, we are doing the derivation, we are writing down the formula. What will be your intrinsic impedance? So the definition is same, but in the end, what did you get in intrinsic impedance? Do you remember? This is what we got. When we calculated the intrinsic impedance formula, this is what we got. So in place of mu naught and epsilon naught, what I am going to put? Mu and epsilon. So same thing I am putting, mu and epsilon. What I am putting? Mu, epsilon. Can I write it down in this manner? Mu naught, mu r, epsilon naught, epsilon r. So what will be your eta? Can you let me know the value of this thing? Yes, that is 120 pi. Mu r, epsilon r. For non-magnetic material, this is something that you can remember, and for non-magnetic medium, mu r equals to 1. So another answer you can remember, that your eta is coming out to be 125. This will 120 pi. This will be taken as 1 only. So divided by epsilon r ohm. This is what you are getting, eta. And what will be the velocity here? Meter per second. This we have already written. So 120 pi can be written as 377 as well, right? So all these calculations you can do in your head only. You will realize, okay, mu by epsilon, mu naught epsilon or 120 pi mu r epsilon r, 1 by epsilon r. So 120 pi divided by epsilon r, that's it. 120 pi divided by under root epsilon r, this will be the formula. So two things I asked you to remember, this and this. And this is a general formula which you can keep in mind. So all the formulas you can derive on your own as well, right? So don't need to mug it up. Now in the next lecture, we are going to analyze the EM wave in lossy dielectric. Now it is lossy dielectric, that means sigma is not equal to 0, rho v is 0. Always we will take charge free region. Okay, mu is equal to mu naught mu r. Now your equations will change because now this guy will come in action. This guy will come in action. So again we will have to do the derivation, but only small change will be there in the derivation. Only a small change will be there. And since it is lossy, so you can understand what will happen with EM wave. It will lose its magnitude. If it started like this, then it will slowly lose its magnitude. Started like this, then magnitude is getting low. So this is how it will travel. So in the next lecture, we are going to see about lossy dielectric as well as the conductor. Okay, lossy dielectric and conductor both are quite same, and free space and lossless dielectric both are quite same. So we have seen for free space and lossless dielectric, right? In the next lecture, we are going to study our lossy dielectric and conductor, and after that we are going to write down the summary as well as we will solve the problems. So after that, all things will be crystal clear. Now at least you can see the EM wave in your brain. Also you can remember some formulas. So if we see the summary, what we have studied, transverse electromagnetic wave, this is true for everyone. Then these are the expression for free space only. For free space, these are the expression. Beta equals to 2 pi by lambda always works. This always works. Beta is equals to mu, beta is equals to omega mu naught epsilon naught under root. Then this formula we are writing. Then if we put the values, Vp equals to 3 into 10 power 8. So in free space, it is traveling with the speed of light. And there, this was the graphical representation. Then we introduced a new term which was known as, what it was known as intrinsic impedance. So that is equals to eta equals to Es by Hs. It is not the ratio of their magnitude, it is the ratio of their phasor representation. Okay, ratio of phasor of electric field to the phasor of magnetic field. So E naught by H naught. Luckily, in this case, it is coming out to be E naught by H naught, because here both were in the same phase. If both were in the same phase, then the ratio will be equal to their magnitude only. Okay, so this was the ratio of their magnitude, and from there we got the expression eta is equals to under root mu naught epsilon naught. So this you need to keep in mind, because in the lossy dielectric, in lossless dielectric, we are going to change it. So eta equals to 120 pi and 377. So this is constant for your free space. So then we solve a numerical. Neta we know, Vp equals to omega by beta we know, Vp is constant, omega is given. So beta value I find out, then I need to find out h. So first we show the direction, and based on that we wrote down the value, and using the value of neta we wrote down the magnitude of h naught, right? Then we saw for lossless dielectric, equations are exactly same, the only difference is this. This is the only difference which I am gonna mark out. This is the only difference. Because of this difference we got the different formulas. Only difference came here, okay? And this was the phase velocity, Vp equals to omega by beta. From there we got this expression, and this is the expression of neta. Neta only difference was 120 pi under root mu or epsilon also came in action. And now we are going to study the analysis of EM wave in lossy dielectric. So the expression will be different, only a few changes will be there. These changes will be there. After that we will analyze about this gamma thing, that new thing is introduced. So we will discuss about it in the next lecture, and then we will see that how to solve those equations using the previous analysis, and then we will write down the expressions. So once we are done with the expression, after that we again see the graphical representation, and all these things we can see, that we are going to see in the next lecture. So next lecture will also be interesting only. It will be mathematical, a lot of formulas we will develop, and after that we will write down the summary and we will solve the numericals. Thank you very much. Let's meet in the next